Still B part 6, exterior algebra. Lecture 7, expression of the wedge product of three one-forms. You see, given the one form, there's a alpha dx b. In this case, let's set here 1, 2, and 3. Then the three forms belong to the cotangent space alpha, wedge beta, wedge gamma, x on three vectors u, v, and w that belongs to the tangent vector. You see? Now, dx1 wedge, dx2 wedge, dx3 acts on u, v, w. You see, you always, remember the definition of a tensor, okay? This over here belongs to the cotangent space, cotangent vector space. U, v, w belongs to the vector space. You see, you act on the tangent vector space. This leads to, let's put here, a scalar, okay, which you want to find out. That's important. We always go to the definition of the tensor. Now, from the previous lecture 6, the first column, the dx1 I set equal u. Then this is the map. You see, that's a map. dx1 belongs to the cotangent vector space. ui, d partial dxi, belongs to the tangent vector space. This is a map. This is a map, a linear map, okay, which leads to a scalar quantity. So this is ui dx1, partial xi. This is ui delta I1. You see, delta I1. This is equal u1. Likewise, dx2 acts on u, the same u. You see, this will follow here. You see, this is u2. dx3 acts on u. dx3 belongs to the cotangent vector space. The u belongs to the tangent vector space. This is a linear map. dx3 ui, partial xi, this leads to u3. So this will be the first column, okay? u1, u2, and u3. The dimension is 3 by 1. That's a column. Now, let's move to the vector v. You see? Then dx1 apply to v, dx2 apply to v, acts on v, dx3 acts on v, which is written right over here, is analogous. You see, that's a linear map. dx1 acts on v, dx1 vj partial xj, this is v1. dx2 acts on v, implies a scalar. dx2 vj partial xj. You see, this is delta. This here, you see, is delta. This 2j. Delta 2j acts on vj is v2. Likewise, this one is delta 3j. Delta 3j acts on vj gives v3. So this leads to the column 2, 3 by 1. The third column, the same. dx1 will act on w, in this case, dx2 on w and dx3 on w. Exactly the same, you see? And just to remember, this over here is delta 1k. You see? And this over here is delta 3k. Delta 3k acts on wk, this give tray. You see? Likewise, this one here is delta 2k. It's quite easy, you see? Now, so grouping the three columns, you see? This is E1, column 2, and column 3. This is determinant of the matrix A. Attention now, A is different from A transpose, but the determinant is the same. That's important. So the connection to the vector analysis, dx1, dx2, and dx3 acts on UVW, leads this connection is analogous to U dot V cross W. You see the mixed product, okay, in the vector calculus. Now extend to M4, you see? So this over here, okay, is a four-dimensional, belongs to the cotangent space, vector space, and this one belongs to the tangent vector space. It's a map, okay, is a scalar, again, by definition of tensor. So this analogous, the determinant, that the column, this is eta 1, eta 2, eta 3, eta 4. Again, the same, you do the same as we did here, you see? So this is a scalar, so the determinant of B is equal to the determinant of B transpose. You can transpose, you see? You can set the first column on this first row, second column, second row, and so on. So, but B, the matrix B is different from B transpose, you see? So, this is this expression, you see, of the wedge product of 3, 1, 4. That's it. You just, as I said, you look at this video, piece of paper, write, and compare. You try to do by yourself. You see, that's it.